so I'll be talking about Conda, a cross-platform package manager. My name is Mateusz Paprocki. I work for Continuum Analytics. I'm not the author of this software package. I had some minor contributions, and I use it every single day. Yeah, so basically, a lot of our people have to put effort into making this happen. I'm just presenting their work. Yeah, so before we begin really this talk, you can, in the meantime, you can actually try this out, because I'll be showing some examples. You can download Conda into phone. There are more ways to install this thing, but those are the two recommended, either through Anaconda, which is just a simple download, 25 megs, and it will contain Python, Conda, and a few minor dependencies. And then you have Anaconda, which is a full distribution. There are over 150 packages per, so scientific packages and some web servers, testing infrastructure, and so on. But this is a huge download. I should say, but those slides are fairly interactive. All those links should be alive. So basically, if you look this URL, you can go to node.js.github.io and PyCon-2015 and Conda. Oh, and you can find those on the appropriate websites installation instructions, but here for convenience you have direct links for various platforms and some installation instructions. This is simple, just on Linux you need bash, or on Windows those are executable installers, so it's even easier. Okay, so the plan for today. I will speak a little bit about Python management, about package management in general, then I will move to package management in Python and discuss the options we have. All should be fairly known, setup.py, wheels, and so on. And then we'll speak about Conda. I will give some introduction, I will show you a few commands, show you what are those Conda packages and Conda environment, because this is also kind of mutual. And then, if time permits, we'll speak about building packages, at the end some disadvantages, because as usual there are some disadvantages, and we'll discuss this. So why do we care about package management at all? So basically there are two perspectives. One is user perspective. Each of us is a user, right? So we want to seamlessly install software. Computers are useless without software. We want to install software. Some of us may not be experts, and basically most users are not experts, and they don't want to care about the details of installing software. This should be as easy as choosing package name, clicking install, or writing a tiny command in a console, and this should be it. And unfortunately, in Python community, it's not exactly as simple as this. Okay, and there is developer's perspective. Some of us are developers, and we want users to use our software. So we also want to seamlessly give those users our work, right? So we also don't want to. We not always want to deal with all those details. After all, we don't want to waste time. We don't want to repeat the same thing over and over again. Okay, I want to work on my package, and I don't care anymore what's going later. It should be as simple as one command. Once again, it's not as simple. Okay, so what is a package manager? First of all, this is software. You still have to install somehow the software. It either comes with your operating system or your Linux distribution, or you, like in case of Conda, you download some small, or not small package in case of Anaconda, and then you can proceed with the automation process, because this is automation is the key here, right? So we want to install software, configure, this is basically installation, upgrading software to newer versions, right? Remove, and so lots of possibilities, but those are the main things we are concerned. And we want the software management package to resolve dependencies. Obviously, packages need to, some depend, some not, but most packages depend on other packages, and those packages depend yet on some other packages, and this goes recursively. So basically, even you would think a simple package can introduce lots of dependencies. So you don't want to manage this on your own. You don't want to inspect every single package for dependencies and then install them and repeat this process. Okay, and we are also speaking here about reliability. We don't want with every upgrade of your package manager to have our environment broken, which in case of several or even many package managers, it's possible that you often get unusable systems. So this is something you have to keep in mind. Obviously, if you start a package management system and you go public, you should keep backwards compatibility and so on. You don't want to break people's systems. Okay, so some examples of package managers. On Linux, there are lots of options. I just listed two of them. macOS has its own. Apparently, even Windows have a few implementations, just not available by default. And then we have the other side of this picture, which is every programming environment has its own package manager. So there is huge pile of software, basically often duplicating work, but there is some merit to this because there are certain environments have their own peculiarities. So there is some reason for having a different package manager for every programming environment. Okay, and yeah, so let's move to Python package management. So the history. So the history is pretty complicated because we cannot say that nothing happened in the past. There is actually a lot of work. There is a lot of work. There is a lot of ongoing work, for example, with wheels. So I'm not going to go into the details here. Just I want to show you that although the package manager problem in Python isn't, at least in the default distribution, isn't solved yet, there was a lot of work in the past and ongoing work. Okay. Yeah. So what are the options installing software? Python software. So of course we can speak about once again about system-wide package managers. Besides the purely Python options like using setup.py install or easy install or pip or wheels and so on. But why we may not want to use a system package manager? I mean those typical systems, those typical system level package managers. So often packages are missing or are very outdated. So you have to use some other sources, or in the end you end up installing software manually. So it's hard to get, as a developer, it's hard to get packages into certain repositories. I mean, for example, in Debian there are lots of requirements to meet, and often you have to modify your software Debian developers allow you to put packages into this repository. I had such a case where we obligated to split the package because we had some built-in dependencies, right? And the problem is also that for every operating system, for every package manager, you have to duplicate your packages. So basically, you have to repeat this work once again over and over again. And the thing very important thing is that this often requires administrator privileges, and we don't want, we really don't want to have administrator privileges. We don't want to have sudo access, and we are not going to be given in the institutions this access. So we automatically cannot install the software. So we would like to have all the nice features of the package manager, but without administrator privileges. Okay, so let me discuss Python options. So we can start with setup.py install, and this is fine as long as it's pure Python, as long as you don't have dependencies. As long as this is pure Python, then it actually works seamlessly. Just one command, it will download. It will install the thing, and you are done. The problem starts when you have C extensions. If you have also modules written in Python, or you depend on some native libraries, and then it's not that easy. And then you have this very common picture, but you get some error like there is no compiler on your system. That happens a lot, and not every system has to be equipped with a compiler, obviously. When we consider doing this on Windows, if you need to compile something. And this is actually, I made a quick experiment with this. So I just downloaded NumPy, which NumPy is a numerical package, and just downloaded the most recent version and attempted to run setup.py install, and this is the effect. So this is a little too much for an average user. Of course, we can go through this. We can see that there is some dependency missing. In this case, it's Python. It cannot build. The build is unable to build some modules, so we can install Python. But yet again, Python may also have some dependencies. We also may need to install those dependencies, and how many of those tracebacks we'll see in general. Yeah, so this is not a great thing. Actually, after installing Python, this actually built, so it was nice. Apparently, this is I was testing this on Ubuntu, and apparently it comes with GCC pre-installed. So after this minor issue, it actually built. But this is still a simple case, because imagine, for example, installing SciPy, which has a lot more dependencies and a lot more, and those dependencies are a lot more complex. Yeah. So basically, with setup.py, you are your own package manager, and I really don't want to do this on my own. So let's move to another option. The other option is pip. Once again, works only with pure Python seamlessly. With C extensions, it's already a problem, because still you have to compile, and you cannot create packages for let's say C libraries. So, for example, if you want to install this H5Py library, which is quite important in the scientific community, then you have to also have HDF5 installed. And HDF5 is a native library, is like this is written in C, so you cannot manage this with pip, and then something like this happens. So pip install H5Py, right? So it downloads the dependencies, it installs NumPy and Python, and then you get this error that you don't have some header. Obviously, you don't have HDF5 installed, so you also don't have headers, so you can't compile, and we get back to the same problem we had with setup.py. And the one more thing which is wrong about pip is that it doesn't have a true dependency solver, so you can get into very, very nasty conflicts, and not all dependencies may be resolved, or the wrong versions will be resolved. So unfortunately, this doesn't quite work as one would expect. Okay, so basically with pip you are what we can call a self-integrator, but you still have to integrate those packages together. But still, sometimes you just have to build those packages as well. So maybe another option is to use wheels. This is is a fairly new thing in Python, but unfortunately, once again, it works for Python packages, but not for native libraries, so we still can't resolve the HDF5 problem. You, for example, can't build for Python itself, and basically you have most of the problems of pip. Just in this case, we also have binary packages obviously available, and this is basically the story for H5i, where I just couldn't find a wheel for this package. Apparently, I mean for Linux, okay, there is a package for OS X, there is no for Linux, there is no for Windows, so basically this is where installation using wheels is started. Okay, but really there is a true package management problem, which is this thing. Windows doesn't come with a pre-installed package manager, so and building anything on Windows is really hard. And apparently this platform is pretty important, and most package downloads from Conda are actually from this platform. So we have to support this as well, and it's not as great currently. Yes. So basically we should sum up all this what I said with that. We want, as package maintainers, we want people to use our packages. Okay, so let's move to Conda, because Conda is the tool that is supposed to resolve those issues. So first of all, it is a system-level package manager, but it doesn't require administrator privileges. You just install it wherever you want, and then it's Python agnostic, so you can install within Conda, you can install multiple versions of Python. With virtual environments, basically you can have simultaneously multiple, like Python 2.7 to 3.4, 3.5, and so on, and it's the experiment. Right, so Python, HDF5, a native library, H5i, which depends on the native library, or all are Conda packages. So basically you can just ship whatever you want. So you have packages like for node.js and things like this. Okay, it's cross-platform, works for on all major operating systems, major Linux distributions, and so on. As I said, doesn't require administrative privileges, and it installs binaries. You have to build a package. It will contain everything that is just to unpack and then ready to use. There is metadata stored separately from the packages, so you don't have to download packages to know their dependency. You just download the so-called package cache, and then you can resolve dependencies, and then you can, at this point, Conda will download packages if there are no conflicts whatsoever. And it uses a quite sophisticated method to resolve dependencies, so basically there is not going to be any issues after installation. So basically before Conda starts to download any packages, it will resolve dependencies. It will tell you, but it may be not satisfiable. So it will also tell you what's wrong. Maybe you have some conflicting versions, or a package doesn't work with Python 3, and so on. So this is all this you will be about all those issues will be informed before installing anything. Okay, so here are a few basic Conda commands. So just simply installing stuff, listing installed packages with versions and more, and then you can search for packages, obviously, and and then there are those virtual environments, so you can create easily. Let's say if you started with let's say mini Conda and you used Python 2.7, no problem to switch to Python 3. It's just as simple as this. But I will speak about environments in a second. Removing packages, getting obviously. Okay, so there are some more advanced features like installing software into a particular environment, or updating all packages. In this case, in the main so-called root environment, but obviously you can update in whichever you want. You can export a list of packages, you can install from a list of packages, and you have full history of what was happening in an environment. So you can review at some point you updated some library which you didn't intend to. You can revert this, and there are lots of other things. And in the end, you can install Anaconda as well. So basically, you started with mini Conda. When you decide to explore Anaconda, no problem. You can get the whole distribution like this and install it to some environment which is called it's my AM. Stands for Conda. Okay. So what is a Conda package? Because this is what Conda installs. So basically, this is just a simple tarball with all the data and some metadata describing the package. Nothing really exciting here. Obviously, this is, as you can see, this is Python agnostic because you have all those folders, those directories available. So basically, you can create packages for pure Python packages, for packages with C extensions, for Python itself, for lots of different native libraries, C, C++, Fortran, doesn't matter. R packages, node.js, even Perl. And perhaps, I'm pretty sure that there was something more, but I think this list is still pretty sufficient. Okay, so what happens when Conda installs a package? So in this case, we will install, it really doesn't matter, but we'll be installing SymPy. So basically, the tarball first, of course, has to be fetched from some repository, and then it's just archived in PKGS directory in Conda's installation, and then those files aren't copied anywhere by default. They are hard linked, so this is pretty efficient. You just have to unpack the program once, and then all the environments will just have hard links. Obviously, if available, you can switch to symbolic links, and if nothing works, then Conda will automatically switch to copying files. So basically, all cases should be covered here. But as long as your operating system has hard link, this is very efficient technique of managing virtual environments. Then there is some fiddling with shebang so that you can easily run binaries or scripts and so on. It's not only but it works with Python. When importing stuff, you can just run programs from the directory. Okay, and there is some more fiddling in some more complex cases. Okay, so this is how it works. So basically, if you install SymPy, you'll get some. Conda will first of all, Conda will tell you that it's fetching metadata, so that you have most recent versions installed. Then it's solving package specification. So this is where the SAT solver kicks in, and it will at this point figure out that SymPy requires fast cache, and fast cache is the last dependency, and this is all. Right, download stage and linking stage, and basically we are done. Okay, with environments, this is the story is that you use Conda create. Use Conda create command. You provide the name of the package, and then easily switch to Python 3.5 with this equal syntax. Okay, and then environments are just simple list of packages in different directories. Usually under Conda, but this doesn't have to be in the same location. This can be across multiple file systems if you need. Once again, hard links are used to link packages from PKGS directory to the target environment, if possible. If not, there is fallback. And then there is basically you don't have to do what was typically done, like dealing with Python path or simulating something manual, which happens often. Yeah, so the only thing you have to do later on is to activate your environment, because by default you in the environment you are currently working in. So basically you have to activate it. So there are two options here, because one is for Unix operating system where you use source, and it only goes you just activate and provide the number, the name of the environment. Okay, so use cases. Obviously, trying new versions of Python. You can easily explore packages, because environments are really throwaway, so you can just quickly create an environment, switch to it, install some packages, experiments, not useful, deactivate, and remove the environment and move on. You can test, you can have as many Pythons installed as you want, and you can very easily switch between them. And basically, whenever you want multiple versions, multiple packages, lists, and so on, this is the right solution. So here we have an example of what Conda would do when creating an environment. So basically, it pretty much is installation procedure. The interesting part comes after this, because it will tell you, but there are some steps you have to follow to activate this environment, and then it tells you also how to deactivate this environment. So return to the default one. So we activate it. It just changes the path, and we are done. You can use Python from now on. And then you can deactivate it. You don't want to use Python 3.5 anymore. Just deactivate. This doesn't remove the environment, just deactivates it. You are back with Python 2.7. You want to switch to a different one, create an environment, activate it, and you are set. Okay, so there is one more concept with Conda, which is called channels, because obviously not all packages are available not available from continue. We built a couple hundred packages, but obviously there are a lot more available in Python. So this is where channels come in handy, because you can just provide some URL, which is basically under the hood just can be a directory with Python packages, Conda packages, and Conda will be able to install from there. So in this case, I'm using our own repository, which is anaconda.org, which provides, I will be speaking about this in a moment, which provides user account. So this is a user account of CEO of Continuum Analytics, Travis Oleman, and he has a package, for example, this is SimPy. Yes, because by default, for some reason, SimPy, a simulation package in Python, is not available in Conda, but Travis created a package for SimPy available for all platforms, so you can easily install like this. And actually, with Anaconda, you can just use username, so you don't have to provide the complete address. Actually, I never use those addresses. It's just too much typing. Okay, you don't always have to provide the channel in the command itself. You can configure this. So there is .conda.rc, and you can add channels either manually and in the file, or you can use conda config and add channels like this. And you can explore the current configuration with conda info. It will tell you what channels you have and what are the default channels, for example, because there are 4 default channels from which Conda by default install software. Okay, so there is building. I think I will right now skip this and go to sharing and make return to this later, because obviously we have to somehow create packages. So this is maybe later I will explain this thing. But also let's move to sharing, because obviously as developers we want to share our packages. We have to do it somewhere. So by default in Python we have PyP, but Conda has its own source of packages. So this is Anaconda Cloud or anaconda.org. If you are aware of what tools I'm speaking here, previously this was called Beanstar, but this was changed somewhere in the middle of this So this is now Anaconda Cloud. And basically it's like GitHub but for maintaining packages. So basically you have public and private packages, you can have accounts, you can have private accounts, and the nice feature is that you can have build automation, so you don't have to build packages yourself on your own computer, just have to provide the specification of the package, and Anaconda will build it for you and perhaps test it. So packages can have built-in testing infrastructure. So basically everything will be automated, and if no problems will occur, then basically they will be automatically published. So you can very quickly go from having a package on your own computer to having everyone being able to use your package. Okay, and you can also host Conda packages on your own, basically with Conda index command, and basically Anaconda is just a wrapper on top of this, obviously with a nice user interface and a lot of our infrastructure. Okay, so this is the main page of Anaconda Cloud. You can search for packages here, and this is an example. This is one of our projects called Bouquet. So this is how it looks. Basically, you have, for example, information that is available for all systems, and things like this. I encourage you to explore. Okay, so obviously Conda has some as any software has some downsides. So there is a common complaint that Conda ships its own Python. So yes, this is if you install Conda and run Python, then basically you will see this. Some people are uncomfortable about this, so just to make you aware, this is not the vanilla Python from python.org. There are supposed to be no major modifications, so this should be pretty much the same Python, but with some, at least with some slightly modified preamble. Okay, Conda is developed mainly by a single company, but this is open. It's fully open source, is BSD licensed. There is a community around it, so basically I think it's not a big deal. There is a lot of software developed this way. Conda packages can be used by pip, which is another possible complaint, obviously, because pip doesn't know about Conda, but Conda knows. This is something I didn't mention in the show. It's actually a very nice feature, but actually Conda knows about pip, so you can install pip with Conda. You can then install packages with pip, and Conda will be aware about all this, and you will be able to list those packages and so on. So it's not that Conda is completely separated from the community. It can cooperate with what is even at some point Conda was able to internally manage big packages, and even install them, but this was kind of complicated and confusing, so this feature was at some point removed. Okay, more complaints about environments, because I can't say they're Bash or ZSH centric, but basically the default scripts are around Bash, at least on Linux. They're focused on this, but it's not a big deal to create those scripts for other shells like this shell. There is an issue started. There is a solution provided. Just maybe 30 lines of code to get this up and running. Okay, there might be also some unfortunate features, like Conda attempts to update software whenever you try to install something. And this at first may be quite annoying, but really there is a good reason for this. But we always update software, because people don't update software on their own, and then they very often complain that they have some issue with our software or some other software, and basically they're asked, okay, so this is some really issue, but I'm not sure it was already resolved, and then we ask what version they're speaking about it, they said, oh, this is a version from, let's say, 2 years ago. And 2 years in software industry is just is ages. So basically then they had to update to a newer version, and there is no more issue, but this issue doesn't appear anymore and just losing time. So basically this is a way to force people to work with most recent packages. But obviously if the solution is that don't depend on versions, you presume that if you, let's say you run Conda install NumPy without the version number, and you get some version, okay? So you say, okay, this is this installed version. This will be here forever. No, if you want this version forever, say explicitly, and Conda will always take into consideration this version. And if there will be some incompatibility, it will just tell you, but you cannot install packages in this configuration. No problem. You can create a new environment with the most recent version of NumPy or some library and install it. Or just change NumPy to some other version, or just remove this version and completely and update everything. Okay, and there is so maybe there is an example of this. Yeah, so you won't possibly you won't be able to reproduce this because you obviously have to have a specific versions of packages on your system. But I just know when preparing this presentation, this actually appeared, but I was installing IPython in my environment, and this is the download list. So basically you can see, okay, there is IPython, there is Plate, there are some dependencies, and then is Conda. Is it a bug? But Conda is on this list. Conda definitively is not a dependency of Python. It's strange, right? So you can see the explanation here. So you have new installed software, and Conda is not here anymore. It's on the update list because Conda updates very often, close to maybe not every day, but at least 1 release a week. So it's a common scenario that Conda will be updating itself. Okay, and another unfortunate feature, actually this should be considered a bug, but Conda is unable to distinguish whether you installed a package intentionally or not. So basically, if you remove a package, Conda is not going to remove its dependencies. So yeah, this should be considered a bug. There are actually a lot of complaints about this feature, and I think this will be resolved at some point. But actually, when I started thinking about this, it appeared that it's not that big of a problem because with environment, with those virtual environments, you can basically install a software package and immediately throw it away, and you just don't remove packages, you remove whole environments. And personally, I don't remember when last time, not for usual work, when I used Conda actually remove packages. I always remove environments. So apparently this somehow is not a problem, at least for me and many people. But for some it is, and I think this should be resolved at some point. Yeah, and you can see it nicely here. Although the font is a little small. But if you install, if you create a new environment, yes, just with Python, no other dependencies, so you can list packages, and there are how many? 9 packages, right? You install then IPython at 18, you remove IPython at 17, no dependencies were removed. Okay, so I should be finishing. So some final words. As I said, Conda is completely open source. It's BSD documentation. Very nice documentation is available on conda.pydata.org, and source code is available, issue tracker, and so on. Any questions can be directed to Conda's mailing list. And just a final word is that although this Conda comes from the scientific community, but it's not directed to it's not only directed to the scientific community. So basically, it can be used to manage any software. You can easily use it in your work. Okay, thank you. any questions.
I guess you can hear me, so I can speak without the microphone. I used Conda, I liked it, probably I loved it. It solved many of my problems because, in my opinion, pip sucks completely. So, I like it so much, but I don't know many people who use it, and there might be a reason of it just being unknown, but maybe there's some other reason that people don't use it, in production. And in production, I know probably why, because like you build those binaries, so maybe they don't like it in production. But can you? I saw the list of the problems, of the issues, and I understand that list. But can you name some other problems that prevent you from using this in production?
Not really. I think the main reason why Conda isn't as highly adopted as we would like it to be is because it's often associated with the scientific community, and it just this is not considered as this universal tool. And this is basically why I'm doing this talk, because last year when I came to PyCon, basically no one knew about Conda, and people who knew were speaking exactly this. Oh, this is this tool for scientists. We will be just using it, okay? And yes, I think this is the main, because Conda is stable. Conda has lots of packages. It easily interacts with the Python, with a reminder of the Python community. So I don't see a reason why not to adopt it. I think it's just this. Maybe not enough information spread around to people outside the scientific community. So this is basically what I'm trying to achieve here.
So the packages you build, they must be a bit more universal than the ones that I would build locally, I assume, in some cases. Are they not slower, ever? Might this be a reason? People don't want pre-built binaries because they want to build them themselves.
Well, it could be an issue, because obviously if you build locally, you can optimize for your specific architecture. But I think most users, the average user, is not going to see a difference. Is not going to even consider this. Obviously, if you are doing some research and you want to squeeze every cycle from your CPU, you will be building yourself, but this is not what a typical user will be doing. So I don't think this is an issue. It can be, obviously, in some rare situations it can be, but this is the same situation as, let's say, installing with apt-get. Those packages are also built for the most average infrastructure, so they're also not optimized for any specific cases. So in this case, we are in the same situation.
Okay, so with Conda, the files, when you install the packages with Conda, the files are stored in the local user directory, like .local something?
Yes.
Okay.
In case of Anaconda, it will be like, let's say, home username, Conda, and then you have this directory pkgs where tarbos are installed and unpacked. And then you have
environments and
yes, you have a directory with environments, and you have this special this directory with Anaconda is a special environment called root, which contains the default installation. And basically, there is one more directory with metadata. Pretty much, this is actually pretty simple.
Mm-hmm. Yeah, and you said that you can host your own index, right? On your own server, you can have it, and you can mix the packages between this public cloud and your own server. I mean, if I will have...
Basically, yes. Basically, you can replicate this and host all the packages yourself. If you, for example, want to. Okay, so suppose you have a company which doesn't allow you to communicate with the outside world, yes. Then you can just set up a server with all those packages. Perhaps you can set up also on this or another server with private packages which you don't want to share, because this is basically what we do at Continuum. All our software, everything for clients,
that's okay.
Even Anaconda .org is a Conda package, so deployment is. At least it should be as easy. We are not yet there, but it should be as easy as just saying Conda install and.
So you are using this on the production environments
yes.
with software
yes,
that you build for your client.
This is used uniformly across the companies. So this is used every day. It's I can say battle tested. So obviously there are bugs. If you go to the issue tracker, you can see quite a lot of them. But what I can say, but Conda is updating regularly and on a regular basis, and I never had a broken environment. It's always rock solid. Maybe at the very beginning there were issues, but I'm using Conda for almost 2 years, and not a single issue, some let's say broken system, or requiring me to just install all over and recreate my environments. Nothing like this.
Do you have any graphical interface for Conda, or this is simple on console?
Okay, so there are attempts at user interface. Actually, this is my contribution to Conda because I used to work on 2 user interfaces. Unfortunately, they're lagging a little behind. So they are not as useful as we would like them to be, but this will be changed sooner or later. But yeah, there are 2. This is called Anaconda launcher. There is this, which is just an application you can run, and there is also Conda UI, which is a web user interface where you have to start the web browser to Conda. But then you can list all the packages, you can install packages. Actually, Conda is actually pretty advanced. Just the user interface is as great as I would like it to be. But basically, you can do most of the basic stuff and some of the advanced stuff from a web browser, obviously locally. More questions?